Dear students and learners, this is my 7th video of thermodynamics, and we have seen the first law of thermodynamics in the last video, and now how that first law of thermodynamics is going to be applied for various processes in thermal devices. Before going to devices, how the working substance is going to processed in the device to give the output, how the processes is being taken place, is being conducted, or how the devices are being worked, the various environments created to get the particular output should be studied. Okay. So now thermodynamic processes. So now already we have seen what this process is nothing but the sequence of operations, whether it can be a cyclic process or any process. The change of state is achieved by conducting the processes. Okay, so if one process is conducted means the state is changed, the properties are changed. Okay, the properties of the working substance are being changed. Okay, so here relations between the state parameters such as pressure, temperature and volume is being studied here, and calculation of the change in internal energy and calculation of work, evaluation of work and heat transferred and change in internal energy, change in enthalpy are the very important calculations to be done, since they are the final output of the processes. What we want from the process is to have work done. Yes, of course, if we want to calculate the work done, how much heat is being given, how much amount of internal energy was created, and the remaining portion is work done. So these calculation is being done at various environments or various processes. So first we will take a constant volume process. Is nothing but the another name is also known as isochoric process. Here volume is kept as constant. Constant volume. Volume means the space occupied by the substance. So if there is no change in the space occupation, volume means no work done, no movement. Okay, the piston, if it is not moved, means then there is no work in the gas cylinder arrangement. Okay, so here at volume equal to constant, what would happen to temperature and pressure? Temperature and pressure will increase, no change in volume and thus no work done by the gas, right? Next, constant pressure process, denoted as isobaric process, and temperature and volume will increase in these types of process also when pressure is kept at constant. Here by since the temperature is increases, increase in internal energy also takes place. Constant temperature or isothermal process. Isothermal process, temperature means thermal. So here since the temperature is kept to constant, no change in internal energy, no change in temperature. Okay. You can see here the derivations also. If it is for adiabatic process, there is no heat transfer, Q equal to 0, and thus del Q equal to 0 means du equal to minus W. That is, no heat enters or leaves the system. And isochoric process means W equal to 0, del U equal to 0. Okay, isothermal process. Here we are the derivations. And thermodynamic processes for some other processes. Adiabatic means no heat transfer, Q equal to 0. So temperature of the gas changes and change in internal energy is equal to work done. Okay. And isentropic process or reversible adiabatic process means isentropic process means the process is both reversible and as well as adiabatic. Let me tell about the reversibility and irreversibility in another some more videos. Entropy remains constant, so Ts equal to 0. Temperature of the gas changes, change in internal energy is equal to work done. Polytropic process. General law of expansion and compression is expressed by this polytropic process only. PV power n equal to constant. Okay, adiabatic process means PV power gamma equal to constant. And free expansion, when a fluid is allowed to expand suddenly into a vacuum chamber through an orifice of large dimensions. In one room you are keeping the gas, and in the another room if it is perfectly vacuum, then the intermediate um, filter is being taken between the two rooms, means then the gas is rushed towards the vacuum chamber, and in this process there is no any useful work, but here movement or displacement takes place without any useful work, and thus here q equal to 0, w equal to 0, and then du is also 0. Okay, thank you for patient listening, and let me summarize the topics which we have covered in this video. Thermodynamic processes is nothing but the various types of processes by which the devices are working to get the useful work. To get the useful work, we have to work on heat transferred into the system. So how much amount of work heat is being supplied and it is converted into work, and it is wasted or rejected, or how much is taken by the molecules has to be calculated when they are working in the devices. Okay, so for the thermodynamic processes and their enthalpy, enthalpy, internal energy, and work done, heat transfer has to be calculated, and in this video I have explained about the various calculations. And regarding as the part of this thermodynamic processes, we can also study about the relations between the specific heat Cp and Cv, which was explained in one of my video already, that Cp, Cv are the important parameters which decides about the particular substance or the fluid, working fluid, uh, is how much it is capable to absorb the work or heat, absorb the heat to complete that particular task given to it. Okay, so here you can see the at constant volume process, at isochoric process, this Q1 to 2, that is heat supplied, is equal to Cv into T2 minus T1, that is W equal to 0 here, and a change in internal energy is nothing but Cv into T2 minus T1. For isobaric process, it is Q, that is the heat transferred Q1 to 2 is equal to Cp into T2 minus T1, and W1 to 2, that is work done, is also P into V2 minus V1. And change in internal energy for this isobaric process is Cp into T2 minus T1 is nothing but P into V2 minus V1. And here we can find out the relations between the Cp and Cv in a very easy manner, and finally we can find out R, that is gas constant, R is equal to Cp minus Cv. Okay, so universal gas constant R is equal to specific heat at constant pressure minus specific heat at constant volume. Okay, and also we can derive the same Cp minus Cv is equal to R by use of the equation H is equal to U plus Pv. In one of my video it was already shown, which is also equal to H is equal to, instead of Pv we can use RT. Okay, and DH differentiation and dividing by dt you will be getting Cp is equal to Cv minus R. Okay, another one more very important relation here we want to have in all sort of thermodynamics is Cp is equal to capital R by gamma minus 1 and Cv is equal to R gamma by gamma minus 1. Okay, and again, let me recall the various topics which was covered in my 7 videos for first till in the first unit of engineering thermodynamics for 2017 regulations of Anna University syllabus. Is we have defined the various fundamental system, boundary, surroundings, property, state, various types of systems, homogeneous, heterogeneous, and heat transfer, work transfer, heat and work in thermodynamic concept, and boundary phenomenons, path function, point function, processes, various types of processes, zeroth law of thermodynamics and its temperature measurement, first law of thermodynamics and its important and its application for any process and for cyclic process, what is cyclic process, etc. Okay, and the parameter calculations for thermodynamic processes such as constant volume process, constant pressure process, constant temperature process, and adiabatic, polytropic, uh, isentropic, and free expansion processes. Okay, so thanks for listening. We will meet you in next video in which steady flow energy equation derivation will be done, and we can apply that steady flow energy equation for various thermal devices. Okay. Happy learning. Thanks for listening.